Objective 1.1, Graphing Quadratic Functions. Even though this class has already started the year by going through Chapter 1 in the book, it's evident that maybe there were some things that you weren't completely confident with by looking at the test. And so we're going to go through some Chapter 1 lessons again. Hopefully there will be things that are very familiar and won't take a lot of work or a great amount of effort to figure out and to improve. But there definitely were some areas where we feel that you do need to improve and we need to take another look at some things. And so we're going to be quickly going through Chapter 1 again, beginning with this lesson. So today we're going to look at graphing quadratic functions. And you can see here we want to be able to graph a quadratic function in whatever form it may be in. So there are three forms that quadratic functions can take. There's what we call the standard form, which is the f of x equals ax squared plus bx plus c. There's the vertex form, which is f of x equals a times the quantity x minus h squared plus k. And then there's the intercept or factored form, which is f of x equals a times x minus p times x minus q. All three of these forms serve different needs at different times, and so we need to be able to use all three of them to graph and to write equations. So a little bit of vocabulary to get us started. A quadratic function in standard form is written in that ax squared plus bx plus c form, where a is not equal to 0. Now they say that because if a was equal to 0, then the x squared term would be canceled out and it would not be quadratic anymore. It would be linear. So as long as we have some value for our a value, even if it's just 1, then we'll have a quadratic function. B or c could be 0. That's fine, but we just don't want a to be 0. We also want to notice that every time we graph a quadratic function, we will always get a U-shaped graph called a parabola. So that's something nice about quadratics, is you always kind of know what to expect. And there's a key point on the parabola called the vertex. If it's a parabola that opens up, then the vertex is the lowest point on the parabola. If we have a parabola that opens down, then the vertex will be the highest point on the parabola. And then we also know that parabolas have symmetry, that you could draw a line right down the middle of the parabola, and the left side would be a mirror image of the right side. And so that line that you can draw down the middle is called the axis of symmetry. And the nice thing is we always know that the axis of symmetry always has to go through the vertex. So that's a helpful piece of information that we can use to our advantage. So we're going to start with a quick video from Mr. Scott from Prentice Hall. He's going to show us how to graph the standard form y equals ax squared plus bx plus c. And there we go. Give Mr. Scott a second to load here.
Welcome everybody, my name is Mr. Scott. I will be helping you with graphing y equals ax squared plus bx plus c. To graph a quadratic function of this form, we can use this property. This property helps us find the axis of symmetry and the x-coordinate of the vertex. Now we also want to follow these 4 steps. First, we want to find the equation of the axis of symmetry. The property tells us that is x equals the opposite of b over 2 times a. Next, we want to find the vertex of the graph, which is a parabola. And from the property, we know that the x-coordinate of the vertex is the opposite of b over 2 times a, and we can find the y-coordinate by substituting that x-coordinate into the equation. Step 3 of our problem is to find two other points on the graph, one of them being the y-intercept. So we want to find the y-intercept as one of those points. And finally, we're going to reflect the 2 points that we find in step 3 across the axis of symmetry and then draw the parabola. So let's see how to work out these 4 steps on the following example. We're going to work through this together. We're going to graph y equals the opposite of x squared plus 6x minus 5. In this equation, the value of a is negative 1, b is 6, and c is negative 5. Let's use the values of a and b to find our axis of symmetry. Remember, x equals the opposite of b over 2 times a. So we substitute 6 in for b and negative 1 in for a, and that fraction reduces to positive 3. So our axis of symmetry is the line with the equation x equals 3. Let's come over here in the graph and graph that line. This dashed red line represents the axis of symmetry, and let's label it x equals 3. Okay, step 2. Now we want to find the vertex of our parabola. Remember, we want to use this x-coordinate that we just found as the x-coordinate of the vertex. So let's take our equation, y equals the opposite of x squared plus 6x minus 5, and substitute that x value into the equation. And then we just have to solve for y. So what do you think the vertex is for our parabola? Do you think the vertex is at 322, 30, or 34? Substitute 3 in for x and solve for y, and choose the correct vertex, either A, B, or C.
Okay, so go ahead and take a minute to do that. If you need to, pause the video while you're working it out and come back when you're ready to choose. Alright, so what do we think the answer is? Should we go with C?
That's right.
Okay, you are correct. C is the vertex, 3, 4. And the reason we know that is because when we substitute 3 in for x, 3 squared is 9, and we get negative 9 plus 18 minus 5, which equals 4. So now we have the vertex of our parabola. Let's graph it. 3, 4 is right here. Okay, moving on to step 3. Now we want to find 2 points, or 2 other points on the graph, one being the y-intercept. Well, the y-intercept is located at the point when x equals 0. And for x equals 0 in our equation, y equals negative 5. So that gives us the point 0, negative 5 for the y-intercept. That's located here on the y-axis, 0, negative 5. Now let's find another point on the left side of the axis of symmetry here. So let's let x equal 1. and we'll use our equation to find the corresponding value of y. The opposite of x squared plus 6x minus 5. We're going to substitute 1 in for x. Now 1 squared is 1, so we get negative 1. 6 times 1 is 6. And negative 1 plus 6 minus 5 is 0. So for x equals 1, y equals 0. And that gives us a second point. 1, 0 is right here on the x-axis. So now we have an idea, if we connect these points, what half of our parabola looks like. To find the other half, we want to reflect these 2 points we just found. So step 4 is to reflect the points 0, negative 5, and 1, 0 across the axis of symmetry. Go ahead and take some time on your own to do that, and when you have the 2 reflection points, we'll call them, graphed, hit the continue button to move on and wrap up the problem.
Okay, so you can go ahead and do that on your paper. Hopefully you've been following along and graphing as you go. So go ahead and finish this out by reflecting those 2 points across the axis of symmetry. All right, let's finish the problem.
All right, welcome back. Your 2 reflection points should be at 5, 0 and 6, negative 5. So now we can connect our points and draw our parabola. And here's what your parabola should look like. Okay, let's label it. Y equals the opposite of x squared plus 6x minus 5. Well, I hope you found this explanation to be helpful, and do a great job when working with functions of the form y equals ax squared plus bx plus c. Work well.
All right, so a couple of things before we move on here that I just want to point out to you. Oftentimes when you're asked to graph these kinds of quadratic functions, you will also be asked to label your x-axis and to label your vertex. So you need to make sure that you are including things like the x equals 3 when you draw your axis, and the 3, 4 for your vertex when you draw that vertex in. So especially when the directions ask for that, don't forget to label those 2 key parts of this graph. All right, so let's go back to our PowerPoint now. So let's try a similar problem a little bit more quickly now that we have an idea of what we're doing. So we have y equals x squared minus 4x plus 3. If we identify a, b, and c, we can use a and b for step 1, which is to identify the axis of symmetry by using the x equals negative b over 2a. So if we put in negative 4 for b and 1 for a, we end up with an answer of 2. So our axis of symmetry is at x equals 2, and we can go to our graph and draw that in. And usually we use a dotted line to represent the axis of symmetry because we don't want it to look like it's actually part of the graph. And notice that we labeled our axis of symmetry up there at the top with x equals 2. Now we can go to step 2, which is to take that 2 value and substitute it into our equation to find the corresponding y value. So when we substitute it in, we end up with 4 minus 8 plus 3, which gives us a negative 1. So now we have our vertex of our parabola, which is at 2, negative 1. So we can go to our graph and we can draw that in. And again, it's a good idea to label that because that's often asked for in the problem. All right, so now step 3 is to find 2 other points. The video said that one of them should be a y-intercept, and that's fine when the y-intercept is relatively close to your vertex. If the y-intercept ends up being farther away from your vertex, then you may get an answer that's not easy to graph, and then the y-intercept is not a good choice. So it doesn't have to be the y-intercept, but when possible, it's an easy choice. And in this case, the y-intercept is fairly close, so we'll put in 0 for x, and we'll end up with 3 for y. Because remember, when we put in 0 for x, our y-intercept is always the constant of our function. Okay, so there's one point. Now we can choose a second point. So since x equals 0 is to the left of the axis of symmetry, it makes sense to pick another x value that is also to the left of the axis of symmetry. So let's pick 1. If I choose 1 as my x value, I can put that into my equation, and I come up with an answer of 0. So if x is 1, and that gives me a y of 0, then that means another point that has to be on the parabola is the point 1, 0. So now I can plot those 2 points. There we go. Okay, and as he said in the video, you're starting to see what the half of the parabola is going to look like. Now to finish up our graph, we're going to reflect those 2 points from step 3 across the axis of symmetry, and then we can draw our parabola. So we reflect and draw. And we label that with y equals x squared minus 4x plus 3, and there's the graph to our function. All right, why don't you give one a shot now? Pause the video for a moment while you try to graph y equals x squared plus 2x plus 1, and come back when you're ready to check. All right, so as you work through the steps, you should get this kind of information. Your axis of symmetry should be x equals -1. Your vertex should have been at -1, 0. You could have a y-intercept at 0, 1. Another possible point you could use would be the point 1, 4, and then you could reflect and draw. So you would end up with a graph that looked like this. Now, the standard form of our quadratics are a common way for quadratics to be written, but it's not the only way. So we want to take a look at the other forms that quadratics can also be in. And this one is called the vertex form. So you'll see here in the general form that we now have an a value that's out in front. That a corresponds to the same a value that was in the standard form. And it tells us the same kinds of things about our graph. Positive a's open up, negative a's open down, large a's make very skinny graphs, fraction a's make wider graphs. All of that is the same no matter what kind of quadratic function you're looking at. So we have a out in front now, and then inside of the parentheses here we have x minus h. Now this might look a little bit familiar because we talked about this with absolute values last chapter, where we have an h value inside and then we have a k value outside. And they actually are similar to what we talked about with absolute values. H is going to make the graph move left or right. K is going to make the graph move up or down. And so if we take a parabola and we think about where the vertex on the parabola is, if we move the parabola to the left or right and then move it up or down, we've repositioned the vertex based on the moves, because the vertex usually starts at 0, 0. So what that means is that when we are using this form of a quadratic, and we identify A, H, and K, we can tell directly from the function things about the graph. So in step 1, we still want to find the axis of symmetry, but this time all we have to do is set x equal to h. So in this case, since h is 3, our axis of symmetry is at x equal to 3. And remember, just like with absolute value, the minus is part of the form. So when I have x minus 3, notice that the h is positive 3. Okay? All right, so we have the axis of symmetry at x equals 3, so we're going to draw that in and make sure we label it. Then step 2 is to find the vertex. Well, the vertex is simply the ordered pair HK, just like the corner point on our absolute values was. So again, that comes directly from the equation itself. H is 3, K is -4, so our vertex is at 3, -4. That's why this is called the vertex form of the quadratic, because you can just look at it and know exactly what the vertex is supposed to be, which is very convenient. So we'll plot 3, -4 right there. Step 3 is to come up with 2 other points, and again, they don't necessarily have to be the y-intercept. If we look at our graph this time, the y-intercept gets a little bit far away, and if we put 0 in for x, we get a rather large answer. So instead, we'll pick things that are closer to the axis, like a 2. If I put 2 in for x, I work it out and I get a -2 for y. So I know one point that my parabola goes through is the point 2, -2. I could also pick an x of 1, substitute that in for x, work it out, and I get a value of 4. So another point would be at 1, 4. So those are 2 more points that I can graph on the right side of, or excuse me, the left side of my axis of symmetry. And then I can do step 4, which is to reflect those 2 points through the axis of symmetry. So I reflect there, and I draw my parabola. So even though the form of my quadratic is different, the steps are not. The steps are still to find your axis of symmetry, find your vertex, find 2 more points, and then reflect them through the axis of symmetry. It's just how you get those answers that's a little bit different. Okay, why don't you try one quick? Pause your video while you give this a try, graph it out on your paper, and come back when you're ready to check. All right, so again, if we just look at the information first, we would have an axis of symmetry at x equals -2, because remember x plus 2 means an h of -2. Our vertex would be at -2, 3. We could find one possible point at -1, 2. We could have another point at 0, -1. And then when we reflect and draw, we end up with a graph that looks like this. All right, I know this is getting a little bit long, but let's take a look at the third form here quick. And this is called the intercept or factored form. And the reason it's called the intercept form is because in this case, when we look at our function, the p and the q tell us the x-intercepts of the graph. Now again, notice that the minus here and here is part of the general form. So when we see x minus 1, that means we're really talking about a p-value of 1. And when we see x plus 3, then we're really talking about a q-value of -3. Also notice again that we still have an a value. That a is still out in front, and it still has the same effect as the other a's. A positive a opens up, negative a opens down, big a's make our graph skinny, and A's like this one, where it's a fraction of 1/2, means our parabola is going to be a little wider than normal. But identifying P equal to 1 and Q equal to -3 automatically tells us that we have x-intercepts at those points. So before we get into our 4 steps, we're going to go ahead and just graph those two x-intercepts. So there's our +1, there's our -3. Now we can start going through the steps. So we need to find the axis of symmetry. Well, if you think about this for a second, we already know where the x-intercepts are. And we know that parabolas have to be symmetrical, which means the axis of symmetry has to run right down the middle of my two x-intercepts, which would be at -1. So x equals -1 is my axis of symmetry. I can draw that line and label it. If I want to be able to do this algebraically, then it's simply a matter of taking the P plus the Q and dividing it by 2. You're actually just taking the arithmetic mean, or the average, of your two x-intercepts to find out where the middle is. Okay? So now, if this is our axis of symmetry, we can then find the vertex because we now know x has to equal -1. So we substitute -1 in for the x's, and we get a y of 2. So the vertex is going to be at -1, 2. So now we can draw that in. So we already have 3 of the 5 points we normally are looking for. So we don't really have to look for 2 more points in step 3. We only have to find 1 more point because we already have the intercepts. So I just need to find 1 point for step 3. Preferably choose one that's beyond the intercept so you get a good feel for what the parabola is really going to look like. So I chose an x equal to 2. Substitute that in, work it out, we get a -2 and 1/2 as an answer. So I plot that point right about there. And then in step 4, I just reflect that 1 point from step 3 and draw my parabola. So again, the steps are the same. We're still going through the 4 steps, but before we start the steps this time, we're actually going to start by plotting the x-intercepts that we can identify from the form of the equation. Alright, so last example. Give this one a try. Pause your video for one more time and come back when you're ready to check. Alright, so based on the equation, we have x-intercepts at -3 and +5. We can establish the axis of symmetry at x equal to 1. That means the vertex would be at 1, -16. We could draw a point somewhere like 6, 9, and then reflect that point when we draw our parabola. So because we have 16 as a y value, we may need to change our scale on y a little bit, because we need to make sure that our parabola fits the graph that we're given. Alright, so I know that's a little bit longer than usual, but I wanted to just talk about all 3 ways of graphing all at once so that when you go to your practice problems for Objective 1.1, you can use any of the methods that fits the type of function you're being given. If you have any questions on this, you can go back and rewatch a section. You can use other resources to help you out, like your textbook or emailing, asking questions of each other, whatever you need to do to make sure that you fully understand how to graph quadratic functions no matter what form they're in. And then when you finish your practice, make sure you check those answers on Canvas. And let me know if you have any questions or issues that you need to work on. I am going to be gone for about a week because our school is going on an interim trip, so I may not be totally available by email all of the time, but I will check when I can. And if you have any questions, I'll try to get back to you as soon as I can. So work hard, and we will see you next lesson.